doing the introductions this week?
Yeah, so we're doing the motor mount, right? The motor and the
Yeah, just motor mount.
Okay.
Did you start recording? Testing.
It's working.
Okay. So, it's actually recording my face. Good. So, hello, my name's Chris, in case anyone didn't come last week, and today we're going to be running through Inventor and basic 3D CAD. With me here is Joel, who's going to be helping out with the course. So the first thing with Inventor and almost every single other CAD program is setting up the units. So from Inventor, you want to go Tools here, Application Options. Then you want to go under File, Configure Default Templates, and ensure that it's in millimeters. And you can use the, well, I use ISO normally. Do you know what the others are for?
ANSI is like American, basically, from Great Britain. A few other ones. But ISO is like the best one to use, especially in Australia. So like millimeters.
International, is it?
International Standards Organization.
Yeah.
Yeah.
Close. So has everyone configured their units properly? Can I just get a hands up once everyone's configured their units?
Yeah, I'll put your hand up if you have done it, and if you haven't done it, then leave your hand down. So only one person's done it. Okay. Do you need help? Okay. Do you need help? Just keep going.
I'll show where everyone it is. Yep. Yeah, they're all on YouTube page, so currently we're streaming the entire thing right now. So this might be a very awkward thing to watch afterwards. Okay, so you'll be seeing this page when you first load up Inventor, and there'll be roughly 4 things: parts, assemblies, drawings, and presentations. So the basics of the 3D CAD is the part. Once you make up several parts, you can actually assemble them and see how your parts fit together. And then from there, you can actually take out technical drawings, which you might send it to use as documentation. Or you may chuck the model into presentation mode, where you can take out exploded diagrams and other diagrams from it. So first up, let's start with the part. And give it a moment.
So just while you're doing that,
Speak with me.
Yeah. Where are we? Okay, so just going back to new, you can see here in the new menu there's a few different things. So with 3D CAD, especially 3D CAD designed for industrial design, there's a few different things that you can choose to create. Generally, when you're creating something to get manufactured, it'll be a series of parts all joined together, kind of like how a car is what you'd call an assembly, whereas a car is assembled out of parts. So with Inventor, you can actually create parts one at a time, and then you can import them into an assembly file where it kind of joins them all together in an appropriate way. And often, if you're actually creating a really complicated assembly, such as a car or an engine or something, a really good way to create these parts is actually while you have them in an assembly, because you can actually make parts reference other parts. So say if you wanted a wheel that you can guarantee isn't going to touch the other wheels, then you would design that wheel in an assembly with all the other wheels in there. So that's just like a quick overview. We'll be coming back to assemblies later.
Yeah.
Yeah.
Do you want to talk about planes? Start from schedule. Start the schedule.
Yeah, this computer's a bit crazy. Anyway. Okay, so here you've got your blank screen. Everyone's got their new part created. It's an empty. Okay, so when you create a part, usually the first thing you'll do is create a sketch. So that's what we'll do now. Now, this empty space here is basically 3D space. It's just empty. There's nothing there except there isn't nothing there. There actually are a couple of things there. There's the actual origin. So if you think back to high school level maths, you have the Cartesian plane, you will have the origin, you'll have the X and Y axis, and if you're in 3 dimensions, you'll also have the Z axis. And then based on those 3 axes and the origin, you can actually create planes. So they're 2-dimensional areas which you can actually draw on. So if you look carefully, it's not that easy to see, but you can actually see, if I highlight the, yeah. If I hover over these, you can actually see the different planes come up. And
scroll's inverted, so
he inverted the scroll. Okay, so XY plane, XZ plane, XYZ plane. So 3 planes, 3D space, you get the idea. So what we'll do is we'll do a sketch on the XY plane. So you can select the XY plane. And then what you'll do is start a 2D sketch. So that's on the top left. So once you've selected the plane, make sure you select the plane first. Click the top left, that's start 2D sketch. And then it gives you a top view of that plane that you've just selected. So you have your X and Y axes, just like in maths. We all love a bit of maths. So what we'll be doing today is a motor attached to a mount with some screws, just to give you a feel for how an assembly would work. So we're doing a stepper motor, okay. So what we'll do is we'll create a rectangle. Stepper motors are generally like a cube sort of shape.
Google.
Sorry?
Google an image.
Oh, yeah, okay, that's a good idea. That will make more sense. This is a stepper motor.
What's it for again?
So a stepper motor is like an electrical motor that can turn in very, very precise steps. So they use it for like robotics and manufacturing and stuff, where if you want to move something a really, really precise amount, you'll use a stepper motor, because one step in one of these is very, very tiny. So
normally it's about, say, 200 to 400 steps per revolution. So one revolution would have like 200 intervals of the motor.
yeah. So they're not really designed to spin really fast. They're more meant to move things really precisely.
So you'll find them in laser cutter systems, 3D printers. That's how they move the head around.
Yep.
On anchor points.
So we'll make something like this. I've got a pretty good idea of how this is in my head, and I'll simplify it a bit so we don't have to spend a whole week trying to make it. But yeah, we'll just make this, we'll mount it on a plate with some screws, and then you should by then have an idea of how to make things. So first thing I'll do is make a rectangle. Click the rectangle button up there. And when I hover near the origin, it actually goes green. See that? So it's actually snapped onto the origin. So then what I can do is click and drag. And it's asking me for the first dimension. So what I'll probably do is I'll make this 50 millimeters. Okay.
What did you just click? Enter?
Just enter. So the other one I didn't actually manage to enter because I pressed enter rather than tab. But you can still, you don't have to start again. You can actually still go from here. So a really awesome tool in these programs like Inventor and SolidWorks is the dimension tool. So if you select the dimension tool and click the line that we didn't dimension, the vertical line, we can make a new dimension here. And we can actually type in 50 and then enter. And then that is now a fully defined square. And you can actually change these. So you can, if I wanted to make this 30, later on, I could. We wouldn't have to restart. Wouldn't have to make the whole thing again. So has everyone managed to get that done? Yeah, it's pretty basic. Okay. So from there, what we can do is we can actually finish our sketch. So that's the little tick on the top right. So that will take us out of the actual sketching view. And then you can see now that we're actually, we actually have our little box that we made in 3D space sitting on the plane. So the good thing about us actually starting with the actual origin there, where we started, is that it actually knows where it is in space. If you don't constrain it onto somewhere like the origin, it's just floating around and it can actually move if it forgets where it was meant to be. That can get really, really bad if you have a really big assembly file. Okay, so if we wanted to make this from a two-dimensional square into a cube, we would select our sketch on the left there, sketch 1, and we'll select the Extrude tool. So you can see that it gives a pretty good idea of what's going to happen when we use it. It's just going to extrude it vertically. So there you go. So it's just asking me how much I want it. You can actually use these little arrows, which is kind of cool. There's a couple of different ways of doing it. You can do it the other way. You can do it in both directions. That sort of stuff. There's lots of options, but for now, let's just make it straight up, and we'll make this one 60 millimeters. Okay. Inverted zoom is weird. Okay.
No, it's invert scroll.
Invert scroll. Okay. All right. Awesome. So there you go. Is everyone happy with that? Okay. Do you want to?
Do you want me to talk about? Do you want to do all the constraints first?
All the constraints. I'd be more comfortable doing that on SolidWorks. Do you want to do the constraints on here? Okay.
Yep. So with this, you currently have a box. However, if you want, you can actually change the dimensions by going to Manage, Parameters. So going back here, you can actually see that you've got 50 millimeters, 50 millimeters, and 60. However, if you know that your base is always going to be square, you can tell it that this is always equal to D0. This ends up constraining the dimension D1 and means that it will always be roughly exactly equal to D0. So if we were to say change D0 to about 40, it will also change the other dimension while we're at it. And using this, you can actually use mathematical formulas such as no, I don't think we want to square that number. So you want to times it, say 2/3 of that? And that results in a box where the height is 2/3 the width. And the width is equal to the length. Okay.
Okay. Screws. Screw holes. I actually have to try and find the chamfer tool. Okay. There it is. Fill it. Yep. Okay. So we now have our box. You actually saw in the photo that these edges are kind of triangled off. If you see along here on the top, on each edge, it's actually called chamfering. So rather than actually trying to draw the sketch of that, there's a really easy way of doing it, which I'll show you. So what we'll do is actually select these edges.
You may just want to select the tool and then select the edges.
Yeah. Yeah, okay. And then up here you'll see the chamfer tool. You can actually, rather than making them triangular, you can use like an actual fillet, which is a radius rounded edge. But for now, let's just do chamfer. So the two ones that I've actually selected are already done, but I'll add in the others as well. There you go. And there's lots of options for this as well. Everything has options. It's crazy, but let's just do, say, 10 millimeters, if that might be too much. 20. No.
No, that results in an error.
Yeah, that was way too big. Yeah.
Go to the left, the left-hand side panel. So there, you can see the chamfer already before I started.
You do it.
Okay. So since we've already applied a chamfer, we can actually go here and edit something that we've already started doing. So we can edit that. So we chamfered at 20 millimeters, which was actually the limit, and it resulted in a square box for us. So if we were to change that to about a 5 millimeter one, it results in this. So here on the left hand side, you can actually go in and edit each part as you go. So if you're, say, not happy with your original shape, you can go back to here and add the sketch. And here you can see that this is actually a function and is equal to dimension 1, which is this dimension here. So exiting that, you can go exit sketch and go back out. If you're not happy with the feature, you can right click and edit the feature, which is this extrusion here.
Okay.
Well, that's close.
So does everyone have chamfered edges on their boxes? Or does anyone need help before we go? You good? Or you need help? Okay. And then what you can do is you can actually press shift and middle click and drag. And you can actually drag around that. Or you can actually start going to the bottom. Okay, we're all good? Or? Hey? Oh yes, I'd be way happier using SolidWorks, to be honest. Anyway, let's edit this.
It seems unfair, but it's Russian, I guess.
Okay, are we ready to move on? Yep. Just 30 more seconds.
But that is, if you want different edges, right? Different edges have different chambers, then you start creating all this. So you just delete those extra ones. No, you wrote create all four again. So you can just delete those.
Okay.
Yeah, so you can write it.
Okay, we'll move on now. So what we're going to do is make the actual motor shaft, and we're going to make it as part of this part because it's just going to make it a bit quicker for us to get the actual demonstration done. So I'm not going to make the shaft and the actual motor housing separate. I'm just going to make them as one part.
Just make a shaft here.
I will. Yeah, I won't make it in a separate part though. Let's do it in the same one.
Shaft in the same one, the housing in the separate one.
You mean the mount? The mount will be in a different one. Yep. Okay.
There's screw holes in this one.
Just screw holes. So we'll just have a block with screw holes.
Sorry?
Yeah, we'll just do that.
Yeah.
Okay. All right. So what we'll do is select the actual top of the motor or the bottom of the motor.
You can use this hole tool if you want to do screw holes. Or you
No, we'll just because I'm trying to demonstrate like
yeah.
other stuff.
Use the
Okay, so we'll select the actual top of the motor, and when we do this, we can actually draw sketches on planes or on surfaces. So if we do that and we go to Start 2D Sketch, we'll actually be able to start drawing on top of the motor. So that means we can actually build on the extrude that we made before. And this is how you make parts. You just build and build and build on things. So what we will do first, okay, what we'll do here is we'll make some construction geometry. So we'll select the line tool. And you'll see as you go over certain nodes here, vertexes of the other geometry, they'll go green. So what I'll do is I'll draw a line from there to there until it goes green. Click. And press escape to stop drawing lines. And I'll do the same on the bottom. And then I'll do the same vertically. There you go. The other reason I did that is because I actually wanted to evenly space the holes that we'll be making. And this is just a really convenient way of doing that. There's loads of different ways you could do it, but this is how we do it here. Just a second, I'm just going to figure something out. Okay, so now that if you actually, I'll go back in so you can see. So once you've done that, you can actually finish the sketch and exit out, like so. And then what I'll do is I'll make another sketch over the top on the same plane as we made before. Start another sketch. So actually this sketch is going to be a separate sketch to the one we just made. Then what we'll do is we'll see these intersections here. I'll make a series of circles on these little cross sections or these intersections of the line, and I'm not going to actually worry about how big I make them, because we can actually fix it up later. Press escape to stop making circles. I'm just going to select all of the circles. Yeah. So, yeah, you should be able to. So, once you've made the 4 circles, and there will all be different diameters, you can actually go into this area here called constraints. And then on the bottom right of that, there's a little icon which is equal. What that'll do is it'll make all of the circles you just selected have the same radius or the same diameter. It's really handy if you're making millions of things at the same time. And then what I can do is dimension one of these circles, and when I change the radius of this circle, all of the other ones will change with it. So I'll make this, say, a radius of, or diameter, sorry, of 3 millimeters. Oh, okay. That did not work. So what happened then is when I changed the radius of all the circles, they weren't constrained to the intersection of those lines, they were just floating in space. So what I'll have to do is actually constrain them properly so that that doesn't happen again. The name of the tool? I'm just clicking.
Do you want to lock trace over to?
Actually, all I'm trying to do is make it like. Yeah.
You can't coincident in 2 separate sketches. You can, however, trace over the previous line and create it as construction.
That's what I was trying to do.
So
This is why I don't use this.
So what you want to do is.
So just go to the other one. Just delete this sketch.
Do you want me to show you an easier way to put holes in?
I'm just trying to show. I was trying to make construction geometry, but in SolidWorks it's totally different to this. So.
So what? Okay, we'll just finish the sketch.
Yeah.
Delete that.
Yep.
This one.
Yep.
Go into here. You can take these lines.
Yep.
And you can go up here.
Ah, that's what I was looking for. Yep.
And that will turn them into construction.
Yep, perfect. Okay, did everyone see that? We're going to redo. I just completely stuffed that last part up.
Sketch 2.
Okay, so yeah, so I'll just get out of this. Finish the sketch that you were just doing with all the circles.
And just delete it.
Just delete that sketch. Then right click on the first sketch that you made and edit sketch. Then what you do is just select all of the lines that you made in there, and there's an actual icon here called construction, and what it does is it changes them to a dotted line, and it doesn't actually use them for making geometry, it uses them for referencing geometry. So it means that we can actually constrain the circles. We can constrain the circles and then it won't allow them to move around. So yeah, do that. Make the circles again.
And it should theoretically snap.
If it does, that would be awesome. Okay. And equal and dimension. There we are, that works. I said at 3 millimeters, yeah. Okay. Then what we do is just finish the sketch. And then what you can do is extrude. Now there's an actual tool in Inventor and in SolidWorks for making screw holes, but we're not doing that now because we're kind of just too early on to be covering lots of different stuff. So we'll just do it with an extrude.
Extrude cut, so you want, there's a options in the middle, and that's the cut.
Yep. There's an actual intersection one as well. I'll show you all the different ones.
What are you trying to do?
I was just trying to preview it while I'm...
You haven't selected the profiles yet. So you select the circles that you want profile.
Yep. Okay, so if I do this option, it's actually going to extrude circles outwards. But if I do this option, it's actually going to cut holes through. See if I can get a top view for you. There you go. So it's actually cut holes right through the middle. And then if I do this option, it actually takes the intersection of them. But for now, we'll just do it as a hole. And let's set the hole depth to say 25 millimeters. There you go. Okay, so I'm just going to save this part. Just save it somewhere convenient for now. We'll call it motor. Save. Okay, so we've saved the part as motor. And when everyone's ready, we'll start the next part. Yep.
Don't set as construction line, then when you leave it, sometimes those lines may bisect the circle, resulting in semicircles, right? Half circle.
Okay.
So when you try to extrude, and you select the face, it'll only select half the circle, rather than the whole circle.
Okay. Okay, so everyone's done? Pretty much? Okay. So we'll start the next part. So we'll go File, New Part. So when you make the new part, you'll notice that down the bottom here, there's actual tabs. And you can actually go back to the part that you made before. So there's a part here that we're not doing, all that stuff. Okay, so go back into the part we just made. And we'll make the plate that the motor is going to get screwed onto. Pizza guys. Are you the pizza guys? No. Okay, select the XY plane. Doesn't matter which plane you choose because we can actually reorientate the geometry as we like. So we'll just do XY plane. And start 2D sketch. Okay, so let's make a really cool looking motor mount. Let's go for like, say, actually, do 4 holes, like 4 circles. Actually, that's a bad idea. Hey, you know what, let's just do it in one giant thing. Okay, set all of these to equal. And let's make some construction geometry as well, because it's going to be handy. You can never have too much construction geometry. Well, you can actually. Okay. So select all of these, make them equal, and make them construction.
You already selected it.
There we are. I'm just going to do this.
Oh no, you can select them all at once.
I did, but it just spazzed out.
No, just drag select.
Anyway, sweet. Let's just make all of these equal as well. I think I already did, didn't I?
You already did.
Yep.
You tried it again and it's spazzed out again.
Yep. Sweet. Okay. Next thing we want to do is give these a dimension. Let's make it say 30 and we're actually going to show you how to make this part match the other part later on. So don't stress about actually making these the same. We'll actually make it adaptive. So if we change the motor, this will automatically update to be the right size. It's going to be pretty awesome. Let's make a line for all the circles. I think I made these as construction. Yes, that's fine. Let's make them not construction. I made those construction as well. Stupid. Let's turn that off. Okay, once you're up to that stage, we can actually give them a width. Let's make it say 15 millimeters, good measure. Okay.
I don't even know what the mount's going to look like.
It's going to look pretty bad.
Yeah.
Okay, now the next thing I want to show you is the trim tool. It's kind of, well, it is exactly the same thing as in AutoCAD. So you can actually draw a line, and wherever you draw, it's just going to trim off all the stuff you don't want. Don't trim your construction geometry though. It's going to be annoying if you do. So it'll be annoying for you. Not annoying for me though. Make it all nice.
Also, don't trim the dimension. It does really big.
Did I do that?
No, you
Okay.
didn't.
That would be really weird. Okay. Oh, actually, yeah, I did. Let's redo that. Yeah. Okay. Something is not right.
Radius. Can you specify the radius of your circles?
Well, they're implicit in the actual, or maybe I need to actually make these tangent. No, but they should actually be on there. There you go. I didn't make the tangent. Okay. Does everyone?
What we're doing is making the lines tangent to each other, so the end of the circle will meet up properly with the straight line.
So what we're aiming for is to have every line in your sketch be this like royal blue color, because it means that you've actually properly defined everything.
Do you want to pause and let them all catch up?
Yeah, I'll just pause now. Does anyone?
So what we want to do is extrude all those circles. So our circles Yeah, we don't have anyone to order pizza. I'm running the workshop right now. Jason, he doesn't have the takeout. Okay, so can you just write down the list of pizzas? So,
It's 15, but it doesn't really matter.
pizzas, four pizzas, 2 cheese, like cheese only. Okay, and another. Jason, how many pizzas do we have here? And then we've got to order pizza for 30 is UNSW and workshop. So the original form was for ABUs. Yep, and the rest is rice. 14 pieces before you use. Yeah, just get 4 pieces for even use. Sorry? No, that's not included. So you've got 4 for even use and then 30 for the rest. So 11 pieces for everyone else, 4 for even use. On top of that, so 15 pieces. We go them from last week. 15 pieces. Two, what you would use at least 2 cheese. So 2 of the 4 pieces you would have to have cheese. The cheese only. Yeah.
Click the tangent constraint and then click the 2 lines.
Yep. Okay. Fine. Okay, collection time is 7:15. Okay, so you into your sketch. They're meant to be on the same sketch. Any really going to reference to the sketch, so you don't want that image there. Once you use it, and then you just change this to here. Okay, sorry, constraint. That's same on the other ones. Then you put on the same sketch. So you want on the same sketch. No, that's fine. If it's over constrained, then it should be fine. Yep. Which one? How do you display turn off the constraints? So turn off the display. You do it if you want that origination. Yeah, because we use integrity tools for proof as well. So you this line has a video constraint. Okay.
So you need to make these get stuff.
Yeah,
So you see this little tangent circle on the line? So click that one,
it's already constrained again.
and then click the line into the start.
Yeah.
And you can just keep it.
I told you so it's already constrained. Yeah.
Okay.
I don't have SolidWorks installed, unfortunately. I had to remove it. Yep.
Okay, are we ready to move on?
So you just want to trim? Yeah. It trims it by the nearest geometry. No, what you need to do now is trim. One thing you skip though is constraint.
Okay, let's move on.
So it generates more data, that makes it easier.
Okay, so let's exit the sketch that we just made and extrude it. And we'll just actually extrude it by, say, 3 millimeters or something like that. So a nice 3 millimeter piece of metal. And then click OK. We're pretty much done on this. All we have to do is make the screw holes and chamfer the edges on the screw holes. So click the top face of the plate once you've extruded it. Make another sketch. And let's make some circles. And we're going to make a total of 8 holes in this. Okay, and then we just move on and actually just constrain everything. So let's just make all the circles the same size. Okay, equal. Now they're all the same size, which is awesome. Let's make these ones be in the center of these actual outside edges. Actually made it the same size. Okay, concentric. So these two concentric circles make the circle object concentric to the outer edge that is also a circle. And you can do that for all these.
It takes a circle, takes another circle, and centers the circle onto the center of the other circle. So that means the outer circle, the center of the outer circle is now the center, same center of the small circle.
Yep. Awesome. Now that that's done, let's make some construction geometry for all of these so we can make them all the same length. And our screw holes earlier were 3 millimeters, yeah? Let's just make them 3 millimeters here. Let's get all the construction geometry we made. Select all of it. Let's just make it all equal, make life easy, and then convert it into construction geometry. It's doing that annoying thing to me again.
How are you doing the center ones?
Sorry?
How
I made a construction line for everything, and I just made them all the same length.
Okay.
Okay, once we've done that, and maybe I'll just wait a little bit. Okay. Cool. Do you want to move on? Are we ready, or should I just wait a bit longer? Should I move on?
Yeah.
Okay. So we've got that sketch. Let's exit out of that and cut it out of our plate. So extrude. To select all of the circles that we made. There we are. And then the second button down to cut it out.
You want to just say cut or distance or
Yeah.
drop the distance.
Oh yeah.
Up.
Oh.
So you have
Yeah,
a lot
all.
of different options, so you can go cut all, and it cuts all the objects again.
So if we wanted the hole to be, say, 1 millimeter off the bottom of this plate, we can actually do distance from face, and it would stop, say, 1 millimeter off the other side, that sort of stuff. But for simplicity, let's go all the way through. Okay, and we should have our holes in our plate, like so. So let's just chamfer those, because we're going to have countersunk screws. I'll show you what countersunk screws look like. It's actually one word, countersunk. So that's really what we're after. So you can see it's kind of like a chamfered face on the head of that screw. And what that allows us to do is to actually put the screw into the actual object and have it sit nice and flush so that you can sit things over the top of it. It doesn't interfere with other surfaces, sort of sticks in. So that's what we're after. So you can see here the cross section of this piece of metal that the screw is in, it's got chamfered edges where the screw head sits. So we'll just go ahead and do that. So chamfer. Just click all of them. It's at 2 millimeters. 2 millimeters looks good. There we are. Lovely. And then OK. There we are. Starting to look like a motor mount. Hobby King special.
You need a circle in the middle to actually let the...
Yeah, but our motor doesn't have a shaft. It's just a heater. It's a heater, it's not a motor. Once you're done, just save the part and then I'll come down and help you guys.
So first of all, you need to extrude the sketch first. Finish the sketch. So you need to extrude.
Yeah.
Extrude. You need to set the sketch. Oh, you did the previous sketch?
Yeah, that looks good. It's actually pretty easy.
Best I learn other things.
Yeah.
all these solid lines, you need to convert all of those to extraction.
Are these units in meters? Okay, how about here? You're 0.43 scale. So when you would hire a chamfer, this distance is 2D. How's the so the distance? So there's some sort of 2D. So you need to fix up the number scale. You live on campus? So lucky, it took me 2 hours to get home. So when this is being less than 3 hours, you can have a 9 days. Walking hills.
Okay, let's move on. So we have our motor mount. Have you all saved it? Save it as mount. Okay, and let's make our screws. Yeah. New part. And for this, I'm actually going to show you a different way of making things. It's called the revolve tool. So what you do is you make a 2-dimensional cross section of whatever it is, and then you actually revolve it around an axis, and it makes it like a revolved solid object of whatever that is. So probably the best way would be for me to go on the XY plane and sketch.
Please make sure you're using 2D sketch, not 3D sketch.
Yeah, 3D sketch is just ridiculous unless you have a good reason to use it. And just make like a rough shape of the screw that you're trying to make. So, you know, we have a nice chamfered edge, and go all the way down, close it off. Make sure you have that vertical line in there. I don't know what it's like in Inventor, but I think SolidWorks complains if you don't.
Yeah. It's no closed profile. So
Oh.
you want to make sure that the profile is closed. If it's an open profile, then it'll try and revolve it, but it'll not be surface rather than visible object.
If you really wanted to, later on you could actually model a thread for the screw, but it's kind of beyond the scope of today.
Don't have to model. You can just select 3 and then you can apply thread to a cylinder.
Oh, well, there you go. Nice. Okay. So dimension. Just dimension these. Actually, probably the first most important dimension would be to make this. This is going to be a radius, not a diameter. So our diameter is 3 millimeters, but so that would make our radius 1.5 millimeters.
So if you don't want to do maths, you can just type in 3 divided by 2.
Yeah, because it's really hard. And then our total length of the screw, we actually made it 25 millimeters in.
And we can
We'll modify it, yeah. So we'll make. Oh, what am I doing?
do you want me to stop you from scrolling out? Yep, okay. Now you stop scrolling down at least.
Okay. Let's do that. Okay.
Because I have only 3 mil normally.
Okay.
Because the models I make are huge.
So you zoom out like a million times.
Yeah.
Yeah, so let's make it 20 millimeters. 220. Yeah. Oh, that's better. Nice and clicky. Okay. I made a little step here. You know, like, just trying to make it,
Just make it half a mil.
yeah, 0.5 millimeter, 0.5.
You don't need to type in MM, you just need to type in 0.5.
And then I'll probably make this, I think our chamfer was 45 degrees. So 135. It's my mouse.
Yeah,
Yeah.
135. You can type in 180 by minus 45.
Hey, this guy. Awesome. And then I think, what else was there? Why is it not constrained? Oh. I don't know. There's something I'm missing. Oh yeah, the actual head diameter.
Yeah. Just as 5. Actually, no, make it as a 3.
3? No. Oh,
Just make it free, we can sort it out later.
tiny little screw. Okay. Awesome. Now,
So you finish this.
yeah. So has everyone got their cross section, the profile for their revolve for their screw? Yep. Take that as a yes. That you shouldn't need to specify that. That should be, if you specify everything else, that will kind of be, yeah. Okay. So let's press the revolve tool button on the top left next to extrude. So if you click the profile button, you can actually click the profile. It's already selected because we just drew it. The next thing you need to select is the axis that you revolve around. So depending on which axis you choose, I think that's the y-axis. That will make a nice looking screw for us. Lovely. But if you choose the other axes, you can get some pretty funny looking results, like that, or like.
You can't rotate out the Z.
Yeah, because
There's no way you can rotate out the Z. You can rotate out the X or the Y.
yeah. So yeah, that's kind of dumb, but you know you'll know which one works. So I don't need to explain that.
Okay.
Yeah.
At the top, you'll notice there's a modify. Under modify, there's a thread option. Right near the chamfer. Next to chamfer.
All right. Thread. That's awesome. But actually in CAD you never even need to make screws because you just you've got a catalog. Okay, and we'll make the actual thread, the actual hex. We'll make this a hex bolt, like an actual Allen key kind of thing. So I'll just wait. Okay, let's make the actual the head of the bolt. So just click the top face of the bolt and press sketch. And let's make it one of those crazy ones that you can't actually undo without the specified proprietary things, so no one steals your mad wheels. I don't know, you can choose anything you want. It actually doesn't matter because we're not going to be using this for anything.
Oh, we can make a circle.
A circle, because you can actually, then you can never undo it.
Screw it in.
I was hoping that would be like a polygon type thing in here. There probably is.
Like a star shape polygon?
Polygon, there you are. Polygon tool. Okay, so polygon, just like making a circle. Let's make it like that. If we wanted to make a crazy one with 360 sides.
No, don't crash the computer.
36, done.
No. You need
You got to do it before you do it.
Yeah, you need to type in the number before you do it.
36-sided polygon. Let's do it.
It's a circle.
Well, it's got 36 sides. It's just you can't really see them.
36 sides, can't tell it apart.
Yeah. Anyway, let's stop being silly. They'll do a 6-sided one because that's, you know, what people do.
Don't click OK. OK exits it.
Yeah, I'm so bad at this. Anyway, yeah, sweet. Ah, and it snapped onto there.
Oh, bugger. You've snapped it.
Should not have done that. Cancel. Start again.
Don't snap things
Snapping is bad.
unless you want it to snap.
Done.
So we'll just set this as a M4. No, set it as an M4.
Is that
M4
flat to
is
flat?
Flat to flat.
Yeah.
So say we want to use an M4 hex bit to open this, you set the flat to flat as a 4 mil.
That's way too big. Do M2.
M2.
M2.73.
There's
no such thing. Okay. Finish that and then cut a little bit out, just like we explained before. Chop a little bit out. We'll make it say 2 millimeters in. Just check that I'm not doing something stupid because I normally am. Oh, that's too much. Let's make it 1.5. Yeah. Okay. Our screw is done. So let's save our screw. Save. Screw. Save. Awesome. So we actually down the bottom, all our tabs. Hey?
Do you still need the nut?
No, because
Oh, yeah.
we're screwing into the motor.
Oh, we're screwing into the back of the motor.
Saves time. Okay, so we've got all our parts. So what we'll do is we'll just make sure everyone can catch up from here, and then we'll do assemblies. So let's just all get back up to date together. So no, we're going to do an assembly now. So like put everything together.
So this is how you test if all your parts dimensions are correct. So if you're,
Either one is not correct.
I'll show you how to make it a very easy way of fixing that if it's incorrect. Yeah, so you can thread it and then you can specify specifications, say you want. You can go with the file M3. Yeah, so it's whatever you set it at. And then it specifies the thread. And that give a moment to load. It takes ages to load. This is because it has to search through about 6 gigs of data. Yeah, all this is about 6 gigs of Parlay 60 file path that you installed it.
Okay. So what you'll do is just
You specify the type thread. Yeah. I think you want a imperial threads. No, his whole thing is in inches, so those are all inches. Okay.
If I just age that
So what you want to do is, are you on the ground you sketch? Yep. No. So you want to go construction line, construction, red. Yep. And then draw your lines. So draw. So you might want to do snap with that one down here. Yep. Yeah, just click it. So that's construction. You want to draw all the other construction lines in? Yes, okay. To cancel. Just hit cancel. So you want to draw every single construction line. So you want. And then once you're done, turn on construction. You'll notice that everything automatically turns green. Escape.
I changed this one. Never mind. Okay, inches. This time it's inches only. Inches. Yeah, it's same, right? Just a bigger one.
Yeah, so what you want to do is turn on construction and then draw the circle from the center. Just go down to this.
No, that's where you start. Oh, it will, but I think it doesn't change the existing. Whatever you change, it's in there.
Okay, so you have to turn that thing you don't want to do. Control Z.
Maybe I love inch. It's not
Control Z.
this.
So, okay, so this one, you want to delete this thing, because what you did previously was lock it to this point, which you don't want to lock it. What you want to do, however, is lock them to each other.
Okay. So now go.
We can show you how to fix that. What you can do is draw a circle. Measure circle that circle. Yep, draw that circle. Measure distance. Yep, thank you. Center. To center the circle.
That's also open.
Put that out. Just on that. Cancel. Because you already drew a line at the center point there. So you're drawing, because you wanted one line there, was one there. Yeah, that's why it's all horizontal to the center. So there's no need to actually dimension again. Okay, so you now have all these since they're all equal, they'll all match that.
Is it not? Lost connection. There's no internet. Maybe restart. Try again.
Yeah. Wi-Fi here is sketchy.
Oh yeah, sometimes they just disconnect me.
Okay. Oh, nice.
It's up to you if you want to put the thread in or not.
Would I then put the thread in that model?
You can put a thread in that way, it's not going to matter. It's only if you're this or this somewhere, so there's cut like,
You
you have a screw, you want to send that to the manufacturer to get a screw smooth like that, then you would send, then you
as an engineer,
put a thread in.
see this
So otherwise I'll just make like a plain screw.
Just do that, like with the sharpening.
But I need that threaded, right?
If you want to make sure the screw fits, then you would thread that.
Is it the same process of like running the thread screw?
You split these cylinder, like the thing, and you just, the base inside, and you specify what type of thread you want on there.
Cool. Okay, we're doing assemblies now.
Yeah.
Is there anyone who hasn't caught up so we can actually wait for them? Do you need us to wait a little bit longer for it?
Do you want to just catch them up on this while I go assembly?
Oh, you're happy to hang on?
Okay, so for the next part, we're going to create an assembly. So, file, new, assembly. And give it a moment. So, once you're in the assembly, what you want to do is place all your current components. So, up on the top left here. I'll just wait until everyone's looking. Yep, so up on the top left. Has everyone started making the assembly? So file new assembly. So once you're inside the assembly, you can go place. And what you want to do is, okay, I'm not going to open that. That's all my current. Where did you save the files to? Desktop? Okay. Yep. So what you want to do is select all the parts that you want to place in. So motor, mount, and screw.
Maybe do just like try doing one at a time.
Yep.
I think the first one gets constrained or something. It's grounded.
No, they don't get grounded unless you ground them specifically. So they all get moved in space. So that way, if you move at something, you can move them relative to each other. So what you want to do is just place all your parts in, one mount, two mounts.
Yeah.
Do you put two? Okay.
There's only enough holes for one. Unless you want to screw two mounts together.
We can do something about that. So you got 8 screws. Four, yep. So just hit escape once you're done placing these screws in. So now that you've got all your parts, what you want to do is join them. So you join, so which hole am I joining to?
They're not the right size, so you've got to show them how to make it the right size.
Yep, give me a moment. Yep. So align that to this line here. So once you've, so when you're joining, you want rigid. Hopefully that doesn't pop an error. You go connect. So what you do is connect the first, I'm going to redo this whole thing again just to show you. So I've got the two parts here that I wish to join, right? So I go to joint, and well, yep, so joint. So it's currently on connect. So I want to take this, the cap of this hole, and I want to join it to the bottom of this hole here so that the surfaces are met, and it joins them. However, I need to align this. So I want to align, on this object here, I want to align this hole with this hole here. Sorry? It does not fit, all right? So, okay, how would be the best way of fixing this?
It's probably going to be easier if you use the outer holes for the motor rather than the inner ones.
No, that way I can join the outer to the outer, top to the bottom,
Okay.
and putting one bracket on either side.
Right.
Okay, so, yep, okay. So since you've got them open, it'll actually pop that up. So let me find it. Motor. Should I show you this the parametric way, which is slightly fiddly, or how would you normally do it? Parametrically? Okay, so from here I can measure a distance here to here. Okay, you know what? I'm not going to do that. I'm just going to draw a construction line from... Yeah, I'm just going back to here. I'm just going to draw some construction line from here to here. And from here to here. And I will just take the dimension from there to there, and yep, I'm just going to take that dimension here. So this dimension is a fixed dimension, but that's what I want. So finish that, manage parameters, and I set this as a exploitable parameter. Done. So once I've taken that diameter, this is probably not the most recommended way, so yeah. Okay, so okay. Yep. So I'm just going to go manage parameters, link, all files, motor, and what I want to do is take the parameter D11. So since we know that the holes right here are double the distance from there to there, and we know that this length here is hopefully 30. So let me double check that. Yep, so this length here is 30. So what I want to do is, where's the 30? Take this length here, and what I want to do is take D11 divide times 2. So what it does is it takes the input parameter and puts it in. Done. Like that. So it's just basically taking the parameters from your previous one and putting it in. This should hopefully give it the correct one. Something's still off. Let me just try and figure out what though. Yeah, the holes all match up, so it's correct. Does everyone want to take a pizza break?
What we should do is, because now you've done it a pretty good way, is go and say, okay, now our boss has told us we want the motor to be like this many millimeters, and then now we've done it this way, the motor mount is still the right size.
Yeah. Okay.
After the pizza break.
Actually, I'll just explain the parameters. So the reason why I set up as parametric and made it specifically referencing the motor is, say we want to suddenly change the size of the motor. Suddenly, say we got the specification saying the motor won't work, it's not powerful enough, we need to upgrade the motor to a bigger one. So if we can go back into the original and we snake the motor, say, larger, right? The parameters on this one are going to change. The width here is going to expand. And that means it's automatically going to expand this one. And so the motor mount, yep, I've got to refresh this. The motor mount will increase in size and get bigger as the original gets bigger. So basically what it's doing is it's just taking the data from the motor size and it's then generating the holes on here and this motor mount size to match it. Yep.
That's like the main advantage of this entire software package is that if some idiot measured something wrong or read something wrong, you can just edit it and you don't have to like do any work because everything is done for you.
So you don't have to just rebuild the entire thing from scratch. You don't have to go into each part, manually add dimensions. You've already got it referenced and it automatically pulls the reference data to update it. I say get food because I'm hungry and I'm pretty sure everyone's been hungry for the last 2 hours. And then we'll resume from there.
did you the last bit when you couldn't fit the
How to do again?
mount onto the motor? Yeah, because how did you measure this? Because they wouldn't lock to. It wouldn't lock to that measurement because you can't lock to the center.
No, I constructed these lines,
Mm-hmm.
took the intersection, and locked it to there.
How do you take the intersection and lock it to there?
So I constructed these, right?
Yep.
Then I took this measurement
How
Took
do
it
you-
from
yeah,
this
I
line.
can't
to here.
try that.
Try that.
Is it just dimensions? Yeah, just draw the dimensions.
I think it was under here. Oh, maybe. Was it on the project geometry that you did that?
So how I got this, I just went back into Sketch. I created two construction geometries. So I created the two diagonals. Then I went dimensions. Dimensions. You can select a line to a point. There.
How you? In SolidWorks, when
You want to put a screw?
constrain on it, there's a button and it flips it around.
Wait, what are you trying to do? Constrain it?
Yeah.
Where are you trying to constrain it to?
Into the hole.
You want to put it in this hole?
Yeah.
Join.
Join or constrain?
Okay, you want to constrain it?
Yeah.
Constrain. You want. This is a lot easier. Cylinder. Actually, no, wrong hole. What we want to do is select the inside hole, and we want to select this. So what we want to do is flip it,
That's what I was after.
and that pushes it in.
We actually sized that pretty well.
No, it perfectly fits that. It perfectly aligns two circles. So it doesn't actually size it, it just perfectly aligns two circles.
No, I mean like when we made the screw head,
Yeah.
we guesstimated it as 6.
Yeah.
But like, yeah, we'll just guess it.
Yeah. So I guess I'll show them how to align the rest of it. Do we want to just double check everyone's mount has been fixed up? So, everyone understood how the parameters work. Okay. So, we'll get someone to send it up.
The mic and the
Yep.
stuff goes back in the go locker.
Okay. Can you PM me the pin?
4398.
Okay, I'll get that somewhere.
Listen.
So, okay, I'm just going to go back here in case anyone missed it. So, going back to the mount, we're going to go into the last sketch of the extrusion. And what we did was we got construction upset up here. We drew a line. Okay. From that point to that point, resulting in that line. We then took a dimension tool, selected a line, selected the center of a circle, and pulled the diameter out. Then we accepted this as a driven dimension. This means that the dimension is actually based off the calculations on the software rather than what you're telling it. Once we have that dimension, we can exit the sketch. We can go to Manage, Parameters, and we can set that dimension to be exportable. This means that if the other parts want to read the diameter, read that dimension, it can. Click Done. Okay, so once you go into the motor mount, you can go into Parameters, and then you can go Link, select the file, and you can select the things you want to link. So you can click this to actually link it, and make sure that it's a plus to actually link the dimensions. So you've now got D11 and D12. So from there, I figured that D0, which is in sketch 1, is actually based off the diameter. So going to this sketch here, this line distance here that distance there was the center of the circle to here, which we have already pre-configured that to be this distance between this point here and this point here is equal to this point here to this point to the center. So with the mount, we've made it so that this line distance here is equal to the distance that we measured. And so by doubling doubling that distance, we ended up getting this distance here, which is why I went D11 times 2. So D11 is the import diameter dimension, and I just multiply by 2. 15 is the diameter of this circle, which we can choose to constrain or we can choose not to. However, there is also one other dimension that we can want to get out. So in here, we actually set the dimensions of the screw to be 3 millimeters. So we want to export that one while we're at it. And in the mount, in the diameter, we want to link this, and we want to link this one. So you can see here there's a very tiny green arrow. When you look at it, that is something that you've actually exported as a reference parameter. So something that can be referenced. So I'm just going to import that. And that's D8. So that is the diameter of the screw hole. So in case we ever have to change that. Okay. That's the thickness. And that's the diameter of the screw hole. Yep. You may also want to go into the screw and change that diameter while you're at it, if you want a very snug fit. Or the other way is inside the screw, you can go parameters, link, motor, screw hole diameter, D8 minus 1. And you know that the diameter is, you want it to be equal to D8 underscore 1 divided by 2. Because D8 is the diameter of your screw hole, and you are measuring the radius. You may also want to subtract maybe 0.2 as a tolerance for your screw. Well, you may actually want to make the other diameter bigger as a tolerance to your screw. The other option is you have the dimension of the screw, say this was 1.5 millimeters. You export that, you import it into your motor file, and have the dimension of the hole in the motor equal to double the diameter of the screw, the radius of the screw. That way, should you ever have to change the screw size, it automatically changes the hole in the motor. So I'll just change that to equal to the diameter of the hole, so that the radius is equal to half the diameter. And then in the assembly, so once we've got all the parts here, we can now put all the screws in place. So what we want to do is constrain. We want to make it so that the hole actually fits in. And we say we want this part of the screw to fit into this part of the hole. And then we want to flip it to ensure that the screw actually goes in. So I don't know if you can actually see it on that screen. Okay, actually, you know what? I can just go in here, I can change the material color to magenta. So as you can see, the screw fits right into there, like that. Getting cross sections is slightly more annoying. You've got to do that in presentation mode. So you just gotta put all the screws in. The other way of putting screws in is taking that, and then what you want to do is align cylindrical. Okay, this does not always work. Yeah, so screws you mostly want to put constraints in, like this. So I'm just going to demonstrate again. So you want to insert the screw, place where you want to insert, place where it meets up, and you sometimes have to flip it to actually ensure that it fits in. So, yep, one more. Okay, so we've now got the other mount to deal with. So the other things we can do is we can use constraint this side, So the first one is mating. So what it does, it takes a surface of an object, and then you can select another surface, and what it's going to do is fix both the surfaces. So now this thing will move around, but it will always be stuck to the surface of the other object. However, since we want to fix it, the screws aren't long enough. That's a problem. So we can take another constraint. We can go another surface tangent. So for this other mate option, so what it does is you take a surface, you take another surface, and you join them. So what this does now is, if I can get a good view, it's running horizontally that way. However, it refuses to actually escape that way because the edge of this right hand side here is now aligned to the right hand side of this part here. So the main use of that is, let me just open up a demonstration. I'm just going to use this to demonstrate. Just going to use this to demonstrate the constraints. So by constraining this, I can actually make it so that this whole panel runs along here. And this piece here runs this way. So this is currently my laser card, which is a work in progress. The control tab will scroll you through these. And so if you just want to lock the final piece, if I can actually figure out which way is which. Nope. I want the first selection to be very slightly tilt. Second selection to be this edge here. And apply. That restrains it because I restrained all 3 degrees of freedom. It's now currently fixed as one single object. But there's not much use to it apart from when you're using sliders and maybe some sort of wheel. That's when you will actually constrain it so that you have things sliding against each other. Is there anything I missed? If we actually had long enough screws, you know what? I'm just going to Control Shift save it. Okay, I'm just going to save this as a new file. Save as screw 2. And Okay, so I'm just gonna come around and help, and that concludes the end of this workshop. Joel, any closing remarks?
Not really.
No, I think we covered it. Yep.